It's a great pleasure to be in this virtual session with all of you, 322 participants. That's amazing. So welcome everybody to this briefing session for chemical engineering. I'll not introduce myself. I'm Saif Khan, and I've been at NUS Chemical Engineering for 15 years now, and I've taught thousands of bright students such as yourselves. So before we begin a little bit of a dive into chemical engineering, the career prospects, let me just invite our department head, Professor Lubin, to say a few words of welcome. Lubin?
Hi, thanks, Saif. Good morning, everyone. Welcome to the NUS Chemical Engineering e-Open House. And I really hope that we could meet in person today, and we will try next time, definitely. In the next few minutes, actually, my deputy head, Saif, will share with you the exciting and cool features of chemical engineering. And we will be very happy to answer any of your questions during or after the Zoom. Please consider applying to us, the best chemical engineering department in Asia. Thank you. I'll get back to you, Saif.
Thanks, Lubin. All right, so let's dive into this a little bit, right? So let me first share my screen, and I'll share my screen, and let's see. Advanced sharing options, who can start sharing? Only host, yeah, I can share that. Okay, let me share my screen. Yeah. So hopefully, Praveen, you can see my slides.
Yes, Saif.
Okay, perfect. All right, so folks, let's spend maybe what 10 minutes or so talking about chemical engineering, right? So let's first start with what the discipline of chemical engineering is. It is a classical discipline. Now, chemical engineers are the molecular engineers. We deal with chemical and physical transformation of materials from nature. Now take a look on this slide, right? You see a number of different pictures, everything from vaccines to scotch tape to fuels, right? What you see over here are the very basis of our everyday living, right? We deal with foods, with pharmaceuticals, with semiconductors, consumer products, and fuels. Every single one of these products has a very strong contribution from chemical engineering, right? We deal with the transformation of a handful of raw materials from nature. These include petroleum, natural gas, coal, biomass, air, water, into thousands of value-added products that then make up the very fabric of our modern existence. So things that are as diverse as medicines to computer chips involve chemical processes that chemical engineers are important parts of. So that's our basic discipline, chemical and physical transformation of materials from nature. But let's take a look within us. So this is stuff that is outside us. Let us take a look within us, right? So all of life is sustained by chemical and physical transformation and transport, which means that chemical engineers, the expertise crosses over into the domain of life. Now let's take simple examples, right? At the scale of a cell, every biological cell is a magnificent chemical factory undergoing all sorts of chemical reactions to sustain metabolism, to replicate cells, and to produce growth in organisms. Cells within our bodies communicate with each other chemically, whether it's nerve cells signaling to each other, or whether it is in pathological situations, cancer cells signaling to each other and then dividing in uncontrolled ways. And at the same time, at the largest scales, when we look within us or within organisms such as plants, you have massive pipelines which are transporting fluids, blood, water, nutrients, as well as electrical signals throughout our bodies, right? All of this falls, the understanding of life as a system involving chemical and physical transformation is the province of a chemical engineer. So in chemical engineering, right, when you join for an undergrad in chemical engineering, there is one what question that we try to answer in that undergraduate program. And that is, what are the key physical, chemical, mathematical, and engineering principles that enable one to design clean, energy efficient, sustainable, and economical processes to basically transform chemically or biologically naturally occurring raw materials? Now, if you can answer that one what question over the course of a few years trained as a chemical engineer, it's a very powerful toolkit to answer many how questions that, as you saw in the video, affect our daily lives. We can answer how questions such as, how do you capture carbon dioxide to minimize environmental damage? How do you provide cheap and plentiful drinking water, right? And how do you create new materials, devices, drugs, and vaccines, which improve the overall quality of life? Chemical engineers answer questions like, how do you minimize gaseous emissions? One of the biggest innovations in all of automotive technology is catalytic converters at the back of cars. That's a chemical engineering innovation. How do you create better, faster, and smaller computer chips? Most of you would probably, that wouldn't cross your horizon of awareness, but the principles of making computer chips is layer upon layer of chemical operations on pieces of silicon. And that is very much the province of a chemical engineer. So the undergraduate degree in chemical engineering equips you for a tremendous diversity of problems that you can apply with a core set of principles that you study in chemical engineering. And we have a really exciting curriculum for all of you, with which sort of exposes you to all these areas, and with a strong emphasis on practical and industrial applications. So we've kind of divided up the curriculum into 4 parts. We start with hands-on experiential learning right in year 1 to give you a flavor and a map for all of the core concepts in chemical engineering. And then in years 2 and 3, we dig deeper. We go into individual sort of pillars within chemical engineering, whether it's mass and energy balances, fluid mechanics, thermodynamics, heat and mass transport. And then in year 4, you bring everything together in a capstone design project, as well as maybe enhance your understanding further with technical electives. Now, on top of this disciplinary education, as you may be aware, NUS has innovated tremendously in the general education that complements this disciplinary education. So you will have amazing exposure to a variety of things that complement this rigorous education. These include exposure to issues such as communities, in social settings, cultures, connections between cultures. You will be exposed to the state-of-the-art digital literacy and tools, and so on and so forth. So what NUS has essentially innovated is both in the disciplinary aspects of the curricula, as well as the stuff that complements these disciplinary aspects. So it's a really exciting time to join NUS as a chemical engineer. Now, just some highlights, right? Right in year 1, like in semester 1 and semester 2. As I said, you're exposed to, with hands-on, you're exposed to a variety of concepts that almost give you a mind map for all the foundational concepts in chemical engineering. So in year 1, you'd be able to really think through deep and interesting things like the water networks in Singapore, how we supply and maintain water supplies in Singapore, right through to phenomena such as respiration within us and desalination of water outside us. We deal with phenomena such as energy capture, sustainable energy capture to run households. And then we also look at phenomena in which we engineer chemistry to be able to do many things, make valuable materials, or even capture carbon dioxide from the atmosphere. So our curriculum is designed to give you a real exposure in a very practical way to the variety of problems that you can solve as a chemical engineer. Now, as far as industry is concerned, we have very strong industry connections. We are a very historically a really well-established department with deep connections across well over 200 companies. We have industry mentors and industry talks, so you can really directly engage with folks from the industry. At the same time, a lot of us, including myself, actively do research and development with industry partners. So in my case, I do a lot of my research with the pharmaceutical industry, right? Which is an absolutely critical industry to all of Singapore. And so why choose NUS Chemical Engineering? Well, we are a top 10 department worldwide. We are Asia's finest department. We have really dedicated and passionate faculty, which span across ages, right? So we have the full spectrum of experience. We have multiple award winners, President Science and Technology Award winners, highly cited researchers, and we have very strong core chemical engineering faculty, as well as faculty that are working in innovative interdisciplinary environments. So I think we have a lot to offer you. And if you join chemical engineering, you essentially are set to solve a variety of problems that are faced globally. And we can discuss that in the Q&A. Now, the kind of, as you can imagine, because of the diversity of the discipline, the types of industry sectors chemical engineers enter is very diverse. So what you may most be aware of is oil and gas, but that's just one of the sectors. Our graduates go to the pharmaceutical industry, to the semiconductor industry, foods, consumer products, cosmetics, and even finance, management, statutory boards. So there's a diversity of careers, and we'd be happy to answer questions about that. But this is really something which I want to emphasize is chemical engineering is consistently a discipline that addresses frontier problems as well as current problems, and chemical engineers will always be in demand. As far as employment goes, we have excellent employment statistics with high median and mean salaries across the board, and that's been a consistent feature of being a chemical engineer in Singapore. And as far as admission requirements, again, we can address these in the Q&A session, but these are the basic sort of admission requirements. With that, I'd just like to stop, right? And we can now just move on to an open question and answer session where I'll just stop sharing my screen, and we'll try to answer all the questions that you may have. So happy to do that.
Saif, we have listed a number of questions. You can go through them. Yes.
Sounds good. Sounds good. So, so for someone who is more interested in chemistry than physics and math, would you recommend chemistry or chemical engineering major? So again, it really depends, right? So are you interested in chemistry, but you're also interested in actually making stuff which impacts lives, right? So if you're interested in processes that eventually reach people, chemical engineering would be the discipline. But if you're interested in just the molecular science of chemistry, thinking about catalysis, etc., you could choose chemistry as a discipline. That being said, we have pure chemists on our faculty as well. So as a chemical engineer, nothing stops you from doing pure chemistry. How can chemical engineers contribute to the biomedical tech industry? Now that's a great question, because we just saw a presentation from biomedical engineering. So let's discuss concrete examples, right? Let's talk about COVID vaccines. The COVID vaccine from Pfizer is a vaccine that encapsulates RNA within lipid vesicles that are stabilized in an aqueous solution. How do you make these? That's the province of a chemical engineer. How do you make these stable formulations that can be injected and deliver the payload of RNA without degradation? That is a chemical engineer's job. So that's just one of the many things. When you go to the industry, in the pharmaceutical industry and biomedical industry, if you're looking at making monoclonal antibodies, viruses as therapeutics, etc., the kind of biotechnology that you need essentially involves cellular processing, which is the province of a chemical engineer. So definitely we are very relevant to the biomedical tech industry. Let's see. Do chemical engineers work at chemical plants only? That's a very common misconception. No. So we have, as we said, we have a spectrum of industries that people work with. I've had students that, for example, go work for L'Oreal and make cosmetics, right? Not just design cosmetics. Work for Procter & Gamble, work for Micron Semiconductor. So it's not necessarily just chemical plants. And then you have chemical engineers that enter finance. One of my brightest students went after his undergrad to Boston Consulting Group, and he became the youngest sort of promoted starting staff in BCG. So a lot of different industries.
Saif, there is one question related to IDP double major and ChemEng, if you can take that.
Let's see. Is it recommended to do the IDP double major with chemical engineering? If so, what are some of the applications of innovation and design, right, in chemical engineering? A great question, right? So, so the recommendation is, if you are passionate about it, of course, you should go for it. Now, as far as design goes, chemical engineering, we design processes, right? Processes. Now, these could be large scale or small scale processes. A lot of us deal with portable processes that either process water to make clean water, or small mini plants that make chemicals at the point of care. If you're interested in things like that, you could combine a strong IDP education with chemical engineering. And of course, we have mentorship. So you can consult with us to decide whether that's the route for you. But the broad answer would be yes.
Wonderful, Saif. There's one very interesting question I think we often get. It's at the top. For someone who is more interested in chem than physics, math, would you recommend chemistry or chemical engineering major?
So that's always a question, right? I'm more interested in chemistry than physics. So, well, let's start with this, right? Whichever engineering you take part in, there is some element of physics, right? So you're not going to run away from physics, right? So that's a baseline. Now, to answer this question, right, you have to look inside and you have to ask yourselves, what is it about chemistry that interests you? Are you interested in molecular discovery, for example, right? Discovery of new reactivity. Now, that would be something where you would do a pure science education. On the other hand, are you a maker? Do you like making molecules and then using those molecules? That's an easy route into chemical engineering. I think that would be the broad distinction. Yeah, so that's what we can start with.
Let me put you on the spot again. Do chemical engineers work at chemical plants only?
Oh yeah, I just said that, right? Hey, no, look, we chemical engineers work pretty much everywhere. I've had enough among my own circle. I've had friends who've done PhDs in chemical engineering and gone on to finance or consulting or banking, for example. That's just one, right? But there are many other disciplines where you don't work in chemical plants. So for example, if you're designing cosmetics or consumer goods, right? There's a lot of things you can do as a chemical engineer. Formulate stable suspensions, whether it's vaccines or shampoos. That doesn't involve working in a chemical plant per se. So lots of options outside of chemical plants.
There's one question perhaps the student panelist team can take it on. What exchange programs does the Chemi offer?
Yeah, this, I think we can, Renjie, if Renjie is around, maybe Renjie can respond to that.
Hello. Oh no.
Yes,
Hi.
I can see.
Yeah. Hi. So the CHBE course, with regards to exchange programs, is done concurrently with the NUS engineering. So the school offers engineering exchanges to various universities around the world, including Oxford and Cambridge as well. Yep. So there's a wide range of top universities around the world that you can apply to once you're in NUS chemical engineering. Yep.
Thanks, Renjie. Said, there's one more question. I'm going to put you on the spot again. How do chemical engineers contribute to the food and consumer industry?
Oh, that's a fantastic one. I can take that. For example, I myself am involved in food research. So let's think about this, right? So in the food industry, if you're looking at, for example, encapsulations of nutraceuticals within food materials. So let's say you want to put omega-3 fatty acids inside noodles, but you want to do that in a way that you don't taste the bitter flavor. So they decompose very quickly, right? So thinking about foods as material formulations that need to be processed is definitely within the domain of a chemical engineer. So over the past couple of years, my lab, along with food science, we've designed processes that extrude zero GI, zero glycemic index noodles made of protein and carbohydrate materials encapsulated with nutraceuticals that can be served to diabetics. And we've had a fair bit of success. So thinking about foods as the chemical and physical transformation of foods is well within the domain of a chemical engineer. And basic food transformation processes are chemical engineering unit operations. I often introduce chemical engineering in year one as, let's take a tour through the kitchen. Pretty much everything you do there is something that we deal with in chemical engineering. So
yeah, there's one more question that for Team CHE. There are a few more lined up as well. Is CHB similar to materials engineering? You have explained a comparison across chemistry, requirement of chemistry, physics. This one is an interesting angle.
Yeah.
Go ahead.
We overlap, right? We overlap. We have, in fact, some of the world's leading material scientists in our department, right? But the place where we diverge is once again the maker aspect of it. So if you want to take advanced materials and you want to then transform them into value-added things, everything from solar cells to therapeutics, you're doing a chemical engineering. Let's call upon Professor Lubin. She is one of the world's leaders in using nanotechnology to do theranostics. Lubin, any thoughts about that? The differences, material science and chemical engineering?
All right. Seriously, as the disciplines involves, actually the boundary becomes less clearer day by day, right? My personal understanding is that in the chemical engineering department, we have really a lot of distinguished materials professors. If we really wanted to set the difference between chemical engineering and materials engineering, I would say that we will focus a lot more on the materials processing, the subsequent device fabrication, or to understand the material structures and functions, but with the purpose to link to the applications. So that we at chemical engineering goes beyond pure initial curiosity for material itself, but rather than how to utilize those materials, understand its functions, and then make use of them to create further value-added products and in a large scale. That's my personal understanding.
Thank you, Lubin. Absolutely.
Saif, there's one more interesting question. This is an angle we haven't covered so far. We keep getting this every year in the open day, right? How much focus is given to biomolecular engineering?
Oh, fantastic. we do get this all the time, right? So let's look at it this way, right? Every time I want to do a chemical transformation, but I don't want to do it using, let's say, pure chemistry. Let's say I want to use cells to do chemistry, or I want to use enzymes to do chemistry. We're veering into biomolecular engineering, but the principles are definitely unified. So biomolecular engineering emphasizes that aspect of chemical and physical transformation that is done with the elements of life, whether it's cells or enzymes. But that's still well within the expertise of a chemical engineer. So if I want to do fermentation technology, whether to produce beverages or to produce vaccines, I need a chemical engineer to run the fermentation reactor. It's a massive multi-phase chemically reacting system that needs to be done properly. So yeah, biomolecular engineering emphasizes that aspect, that life itself is chemical and physical transformation.
Thanks, Saif. I have one more question. Perhaps your student team can take it. It's related to combinations available to our chemi students. What is a good combination of a second major or minor in chemical engineering? Either you or the student team can take it.
Maybe the student team can perhaps, Ranjay, you wanna take that? Chun, Suraj, combinations that our students take.
Okay, I think I'll take it. Personally, I'm doing a double degree in chemical engineering and economics, but there are many different minors and second majors or even second degrees that students can take. So the more common ones would be if you do a minor in business or management, or even second degree in business, or I even know a friend who's doing a double degree in chemical engineering and physics. So there's really no bounds to what kind of second major or minor that you want to take in NUS engineering, because it is truly very flexible.
Yes, on a similar note, earlier starting the morning session, our dean presented the wonderful, exciting prospects the new curriculum opens up for engineering graduates. Perhaps stay tuned. We will be putting that video up in our social media platforms if some of you have missed it, and also in our YouTube channel and in our website. Saif, one last question before we let your team go. This is something that I think is very relevant given the changes happening in our industry as well. The question goes as following. With rapid advancement in technology, such as IA, I guess the question is referring to industrial automation or maybe AI. How does these change the role of chemical engineer in the future?
Yeah, so let's answer that it simply, in short, it makes it even more exciting. And let me be very specific. We have state-of-the-art artificial intelligence and machine learning research going on right now in NUS chemical engineering. You will be exposed to it. In very simply, right? Can we make chemical manufacturing faster, more intelligent, and smaller? So instead of thinking about chemical plants, can I have small, intelligent sort of plants that just make the molecules I want on the spot intelligently? That is something I am working on currently as well in my own research. So chemical engineers are naturally suited by their background to interface with computation and machine learning, and essentially to enhance their own operations. So we're working in NUS chemical engineering, everything from molecular and materials discovery using AI through to intelligent processes using AI. And so we're well suited to take this head on and really innovate. going forward in the next couple of decades. So it's a very exciting time.
Thank you, Saif. In the interest of time, we should stop here. Once again, thank you, Saif and team CHBE.